Well, good afternoon. Thank you, Sharnita, and to the National Association of Surety Bond Producers for allowing me to be with you today to discuss this very important topic. I hope you will find the information useful. As you can see on my bio page, on page 2 of the presentation you've been sent, I've been in the business of manufacturing and distributing products for underground utilities for 38 years. Currently, I'm the sales manager for Hancock Concrete Products, but today I'm representing the American Concrete Pipe Association, of which my company is a member. The American Concrete Pipe Association is over 100 years old. It was established as a means of exchanging ideas and setting standards for product design and quality. There are currently 400 production facilities operated by ACPA members in the United States and Canada, and over 40 countries are represented in the membership of the American Concrete Pipe Association. Today, the American Concrete Pipe Association is the spokesperson for the concrete pipe industry in all matters affecting the industry's welfare. So ACPA members contribute to the improvement of our environment by producing quality concrete pipe that's engineered to provide a lasting and economical solution to today's drainage and pollution problems. Today's topic is about risk assessment of underground utility construction. We'll have some time for questions after I conclude, and I would encourage you to be prepared with your questions at that time. If you turn to page 3 of your presentation, in the next 30 minutes or so, I will discuss the following items. The basic differences in the products available for storm and sanitary sewer construction. Although there are many different options, they all fall into the category of either flexible or rigid products. We'll take Engineering 101. That's how very flexible and rigid pipes are designed to work. There are very different installation requirements for both types of pipe, and I'll get into both of those. We'll talk about a case history of the Tindall, South Dakota project, and this is a large municipal project with a storm drainage system that failed, and this eventually led to a bond claim. And finally, we'll talk about the lessons learned from the Tindall failure, and we'll give you some recommendations. Now, before I get started, I just want to say that throughout my presentation, it may seem like I'm trying to sell you concrete pipe. Be assured, I realize you are neither going to specify concrete pipe on a project, nor are you going to purchase concrete pipe. However, my goal here today is to educate you on the difference in the products and the different risk levels that exist with each one. In the concrete pipe industry, we talk every day to design engineers about the risk involved in using some pipe products that are available in the marketplace. But it wasn't until the Tindall failure and the ensuing bond claim that we in the concrete pipe industry considered how important this may be to your industry. You have a vested interest in the success of the companies and the projects that you write surety bonds for, and you certainly assess risk whenever you write a bond. But you may not understand that even though an engineer specifies a product, that product may be much more difficult to install and may place more risk on the installing contractor than other products do. Engineers are conservative by nature, but as is the case with the Tindall project, sometimes a perceived cost savings and performance claims by a manufacturer or even a distributor may lead that designer to use a product that, along with its use, comes a higher risk of failure. So let's get started, and if you'll turn to page 4. All buried pipes must act as both a conduit to convey storm or wastewater and a structure providing strength to support the soils or the earth loads around and above the pipeline. Now, these earth loads vary with the depth of the installation, so a buried pipeline that's 14 feet